Hey people, today I'm going to be making a square wave generator. I don't know if this is going to work or not. It's an old design I made. Probably the worst way to do it, but it's one that I've always wanted to try since I put it onto paper, so let's see if it works. So for those who don't know, this is how a relay works. It is a magnet inside powered by these two pins. So when you run electricity through, it will generate a magnetic field and act as a magnet, but when not charged, there will be no magnetic field here. And when the magnet is charged, it pulls another magnet, just a normal magnet that does not need to be powered, it pulls it towards it. And what that does is it allows it to act like an electronic switch, just like turning off a light. In this case, when you have the magnetic field, it flips the switch. And when you turn that back off, it flips back to its original position. So, for instance, if there is no power in this diagram, if the magnet is not charged, there's no magnetic field, circuit 1 will be connected to circuit 3. But then if we add electricity, if we pump electricity into this and start up the magnetic field, it'll switch automatically, and pin 1 will be disconnected from pin 3, and pin 3 will then become connected to pin 2, so we'll be running around here. And then of course if we turn the electricity off again and the magnet turns off, it will switch back to pin 1. This is just a view from the bottom. This would be pin 3, this would be pin 1, and this would be pin 2. And then of course these would just be the wires to power the magnet. So one thing we'll need for this build is something called a rectifier that converts the AC electricity from a wall to DC electricity similar to a battery. So what a rectifier needs is a diode. And a diode only allows electricity to flow in one direction. So if we have a positive charge here and a negative charge here, the positive charge cannot flow this way to the negative charge because the diode only allows electricity to flow this way. But if we have a positive charge here and a negative charge here, then the positive charge can flow down here to the negative charge and be with its loved one forever. So the way this works in a rectifier is it takes an AC power source that's constantly shifting between one direction of current and another direction of current. It does it gradually in this sort of wave pattern, and it converts it to this different wave pattern, and then eventually to this constant voltage. So if the current is flowing in this direction, then it will flow down through this diode because it can't flow against this one, and into the negative wire. And then the electricity will also flow back up through this wire into the power source. So then if it's flowing the other way, it'll flow up here and into the negative wire because again it can't go against the diode. And then the electricity will also flow back up into here because it can't flow down here due to the diode. So what the capacitor here does is it smooths out these bumps, and it's not super important to understand exactly how it does that. Basically it stores the voltage and releases it over time, like it'll store it up here and release it a little bit over here to smooth it out into one constant voltage, therefore giving us a DC current. Okay, here is the basic design. Runs a whole wall socket, and then basically the way this works is the relay takes in the alternating current from the wall, and so this diode keeps the current only flowing one direction, whereas this just keeps the current from doubling in the rectifier. But basically the relay switches on and off based on the state that the alternating current from the wall is at, and then that switches between, from a rectifier, a positive current and a negative current come through here. And then of course we have a ground for the electricity to flow through. So one issue I had getting started with this is the relay, as you can see here, I've glued like a wire to it, and the reason for that is that the ground here, the grounding pin just snapped off when I tried to fit it to the board. So I went through hell trying to get a wire on there. I tried soldering it, but the metal there wasn't big enough to make a good contact with that. That didn't work. I tried super gluing it, but then the glue wouldn't dry fast enough, and I ended up having to scrape that off anyway. That didn't work. The hot glue sort of worked. I had to try it a couple times. It doesn't seem to want to stick to this surface very well. I had to kind of wrap it around in order to get it to work. But it seems to be working now. But the problem is, obviously, I can't fit it on the board now, so I'm going to have to solder onto these 4 pins. So what I'm going to need to do is basically just make a makeshift third arm so I can hold the relay in place to solder it on. And look at that. That looks like a creepy bug monster, but it should work. Okay, so that tip has been completely destroyed. As you can see, it's in 2 pieces. Thankfully, I do have another one. I had a whole kit that I got this with. Has a couple tips. These are a little old, so maybe that's why they broke, but please feel free to tell me if I destroyed them doing something stupid. So the next step is we need a plug that can plug into the wall to draw power, and I've got this piece that my buddy and I got from Microwave. I already soldered on a little toggle switch just for safety in case something goes wrong, but I am going to need to solder some wire onto this that can actually plug into the breadboard. Okay, so this will be our ground, and I'll need the ground for later on, so... And I'll choose white. So now we just gotta hook it up to the board. I'll hook up this wire here, this wire here. And I'll stick the ground right here. So I'll start with the rectifier and then move on to other parts of the build. And now that the rectifier bridge is complete, I'm going to move on to rigging up the relay where it needs to be. So we're going to run two 12 kilo ohm resistors from the rectifier in order to make sure that we're not going to blow anything on the relay, because obviously an outlet is capable of delivering a lot of current, and you know, I have this strange aversion to dying. And I'm actually using one 10 kilo ohm resistor and one 2 kilo ohm resistor, because unfortunately I just don't have a 12 kilo ohm resistor handy. So now we need another couple 2K ohm resistors. And a couple 10 kilo ohm resistors. So I'm a little nervous that this wire here might have lost its connection. As you can see, it's a little bent here. So what I'm going to be doing is using this little breadboard and this power supply plugged into a wall to test it out using an LED. Let's get it all hooked up. Moment of truth, and it works. Thank God. Ah. Because that joint was so bad, I am actually going to try and extend all these wires in the hopes that I won't have to bend them too much and they won't break. So now it looks even more weird, but hopefully this will provide a good connection without breaking off any of the wires like it did before. Okay, first we'll hook up our positive power wire, then our negative wire, this will be our output, so I'll leave this here. Now we need our AC power. Here and here. And I'll use this LED so that the current will only flow one direction and the relay will only be on half the time. And what we also need is another light emitting diode so that when the current is not going through this part of the relay, it won't be doubling up in the rectifier. Okay, awesome. The last thing we need is the ground wire and an output wire. I'm going to choose blue for the output wire. And there it is. Between these two there should be a square wave. So assuming I built it correctly, this yellow diode should just turn on and off periodically. So in the midst of my fear of plugging this thing in and burning myself alive, it looks like I forgot to actually add any wires that power it. So I'll just go ahead and fix that. Okay, so that should do it for the rectifier. Now we're going to need power for the relay. So unless I'm mistaken, it should be complete. Yeah, I'm not gonna lie, I'm terrified to plug this thing in, but here goes. Okay, so those two are going, and so that means this thing is on. Well, this works. But this isn't blinking. Huh. So I have a theory about what may have happened. What may have happened is the frequency of the wall power is just so high that the magnet inside the relay can't keep up. Like, it keeps getting energized, building up a magnetic field, and that doesn't have any time to dissipate when the current goes down. So it just ends up with basically just one magnetic field, and obviously the switch just ends up not being attracted to it or continuously attracted to it. I'm guessing not, because I didn't hear a click. But my way of testing this is I'm going to use this power supply to supply DC current into here, and if my theory is correct, then this light should only turn on when they're in one arrangement, but then not turn on in the other arrangement. So let's give it a try. Okay, so the red light is on, the blue light is not, and this is off. Let's see what happens when I switch them around. Huh. Still nothing's happening. Is the relay working? I may have broke it. Doesn't look like it's the diode. Huh. So I'm not hearing a click when I turn this on, even though clearly there's current passing through what should flip the switch in there. So what I'm wondering is if all that effort was for nothing and the relay is actually broken. Maybe when I melted that plastic I may have destroyed the insides. I don't know. Well, that was a little disappointing, but we are making some progress. We got the power from the wall working through the circuit without frying anything. We have basically everything but the relay working, it seems. So stay tuned for part 2. I'll work on this in the meantime. See ya.